Hey there, welcome back. You're watching part two of our series on unit conversions. This is a very short lesson that we're going to work exclusively with the metric system. So before we jump into metric conversions, we should at least talk a little bit about the different types of units between the customary or the imperial system and the metric system. So let's first talk about length. In the customary system, of course, when we measure length, what units do you use? There's several of them, right? We use inches, we use feet, yards, and miles. But in the metric system, they don't use any of those. What units are used in the metric system? Well, lots of them, but they're all based on the base unit, which is the meter. And of course, you know that a meter is about the height of a meter stick. So you know how big a meter is. What about mass or weight? When we talk about mass and weight in the customary system, we have ounces for things that are light, pounds, and tons. In the metric system, everything is based on the gram, and a gram is about the weight of a paper clip, so it's a pretty small unit. We often measure in kilograms, which would be 1,000 of those grams, and we're going to talk more about that in a minute. Volume. When we talk about volume or liquid capacity in the imperial system or customary system, it's usually cups, pints, quarts, gallons, but there are lots of others. Teaspoons, tablespoons. But in the metric system, the base unit of volume is the liter. And a large bottle of soda is a liter. They make 1 liter bottles, so you have a point of reference there. When we measure force, think about how tow straps are rated, or chains. They're rated according to how much force they can handle. That is to say, that's measured in pounds. But in the metric system, that force is measured in newtons, and that's why torque has a unit of newton meters instead of foot-pounds. A newton is a lot smaller than a pound. A newton is around 1/4 of a pound, though not exactly. Power output in the customary system, typically we use horsepower to measure how much power an engine is producing, but in the metric system, the watts are used, sometimes kilowatts. Now all the rest of them, these electrical units, are actually the same. Both systems use volts, amps for current, ohms for resistance, and hertz for frequency. So no difference in all those electrical units. So there's lots of different ways to convert in the metric system, but this is what I think is the simplest and most intuitive way. For any type of unit that we're working with, we have a base unit like liter, or volt, or meter like we just saw, but we can put a prefix on those that gives them some multiple. So for example, if we have 10 liters, we can call that a decaliter. 100 volts would be a hectovolt. 1,000 ohms is a kilo ohm. And 1,000,000 of any of those becomes a mega unit. So we could have a meganewton or a megaliter. If we have less than one, we have other prefixes. 1/10 of something is a deci. 1/100th of something is a centi. That's why we have centimeters, because those are 1/100th of a meter. Milli means 1,000th. A millimeter is 1,000th of a meter. And we have micro, which means 1/1,000,000th. Now the staircase is an easy way. It tells you exactly how to move the decimal when you're doing a unit conversion. So let's take a look at that. Okay, here's how the metric stairway works. Suppose we want to convert 5.75 decavolts to microvolts. Okay, so we'd be going from deca, which is right here. That's 10 multiples of 10 volts. And we want to go to micro. All we need to do is count how many places we're moving on our staircase, and that tells us how many decimal points to move. So from deca, it's 1 to base, 2, 3, 4. Now the end steps, where it says 3 extra, we have to count as 3. So we're at 4. We're not going to call it 5. We're going to call it 5, 6, 7, because that's 3 steps. So it's 7 steps. And most importantly, it's not just 7 steps, it's 7 steps to the right on our stairway. So we're going to move that decimal place 7 places to the right. 5.75 becomes 1, 2. Now we're going to have to tack some zeros on. 3, 4, 5, 6, and 7. Zeros will occupy the rest of that space. And so that means our measurement is 5, 7, 5, 0, 0, 0, 0, 0, commas every third place from the right. And apparently it's 57,500,000 microvolts, and we're done. The other thing that the stairway tells us, not only did it tell us to move our decimal place 7 places to the right, but we went down on the stairway, and that tells us that we are going to a smaller unit. When we move to the left, we move the decimal to the left and we're going to a larger unit. Let's do another one. 7,500 kilohertz to megahertz. All right, here we're going from the prefix of kilo to the prefix of mega. Now that's just one step to the left, but it's in the 3 extra range, so that's equivalent to moving 3 steps to the left. So we start out with 7,500. Note that the decimal place is at the end of that number if it's not shown anywhere else. And if we move 3 places to the left, that puts the decimal between the 7 and the 5, so this is 7.5 megahertz. Because we went to a unit, to a larger unit, we don't have as many of them. 7.5. I want you to do this one for practice. Convert 865 watts to kilowatts. Okay, there's no prefix on watts here, so that is our base unit. So we're going from just a plain old watt to kilowatts. That's going to be 1, 2, 3 steps to the left. 865 is what we're starting with. The decimal must be at the end of that number. 1, 2, 3 to the left means we have 0.865 kilowatts. And that's all there is to it. So then the question is, well, how do you have this metric staircase? On your conversion sheet that you've used in part 1, you have all your conversion facts. There's a blank metric staircase. You can fill in those prefixes on this staircase so that you can use it when you're doing your practice problems and skill checks. So take the conversion sheet you printed out and go ahead and fill in all the values from that metric staircase. Okay, the Audi A8 produces 180 kilowatts at 3,500 RPM. How many horsepower is this? Well, in Europe that would be advertised as 180 kilowatts, but for the American market we would want to know how many horsepower that is. So we have a conversion fact, but it's not quite what we need. We know that 1 horsepower is 746 watts, but we don't have watts, we have kilowatts. So what we need to do is we need to change 180 kilowatts to just watts. So on our metric staircase, if we're going from kilowatts to just plain old watts, that's to our base unit, we need to move 3 to the right. So let's do that. 180 kilowatts becomes 180,000 watts. And that makes sense because kilo means 1,000, so 180 kilo should be 180,000. Now we want to go to horsepower. So now that we've done this metric stairway move, we're going to use cancellation to get the rest of the way. 180,000 watts. And we'll trade in 746 watts for every horsepower. Watts cancels. 746 is on the bottom, and that means we can do that division. So 180,000 divided by 746 is 241.3 horsepower. Or it would certainly be reasonable to say 241 horsepower. And that's that. So here's a case where we had to use the metric staircase to do part of our conversion, and then we had to do cancellation to do the second part of our conversion. So I'd like you to do one problem just like that one. Tell me, if the resistance of a certain action-weighting motor should be 2,550 deciohms, then I want you to tell me how many kilo ohms that is. That one you can do according to a straight stairway. Take a minute, do that, and we'll bring this to a close. Okay, we're going from deci to kilo. Let's take a look at our stairway. Okay, from deci to kilo, we're going 1, 2, 3, 4 places to the left. And if we're going 4 places to the left, then 2550.0 is going to have its decimal moved 4 places over. And this becomes 0.255. And you could leave the 0 on there, it doesn't really matter. But 0.255, and those are now kilo ohms. And we're done. Okay, that takes care of this short topic. There's some practice problems that'll have you doing some metric conversions. Make sure that you copy this stairway that you see here. Make sure you copy that onto your conversion sheet so you've got easy access to it, and make sure that you're able to use it. And as always, let me know if you're having any trouble, and I'm certainly happy to help you out. We'll see you soon.